What's up, guys? Let's do this transient state problem, which is from chapter 11, problem section. It's number 2. And yes, I think you should read the problem first and then I'm going to help you. So pause the video, read it, and then I'll continue. So we're talking about 150 kilomoles of an aqueous phosphoric acid solution. So you have a solution that contains, they give you this percentage, which is, let's change it to fraction of phosphoric acid. I'm going to use P, and water, of course, I'm going to use W. Okay, we have this data, and they tell you the solution is concentrated by adding pure phosphoric acid at this rate here, which is volumetric flow. We're going to need to change that eventually to moles. You're going to see that later. And let me tell you about what they're asking us to do. So probably we have this in a tank, and they add this here at 20 liters per minute. So you have here phosphoric and water, which is here. What you will expect is that eventually the level is going to go up, to have more phosphoric acid than before. And yeah, let's say this is time, the final time needed, and this is the initial time. And you will have, this is the concentration at initial time and the concentration at final time. We don't know it. And actually we also don't know at what time we're going to do it. So they tell you letter A, please write the differential mole balance, which is essentially just do the mass balance on phosphoric acid. Very important here, not the water, not the total mass, but phosphoric acid. And please give the initial conditions, which we already have here. It's initial concentration, initial time is equal to 0, of course. And they give you this tip. Start by defining NP to be the total quantity of phosphoric acid in the tank at any moment or any time. So let's do this. First of all, let me go here. We're going to do mass balance. You know, from the mass balance equation, inlet minus outlet plus production minus consumption should give you the accumulation in the system. So let me tell you why we are accumulating stuff here. First of all, you see the tank here, and you're adding 20 liters per minute. You know, as time goes by, you're going to increase the level at this volume level and mass level of the tank. So as time changes, you know the definition of transient state. When time changes, something or variables changes. So we are going also not only the level or volume, we're going to change also the concentration because we are adding more phosphoric acid. So eventually you're going to get more phosphoric acid here, and you're going to concentrate it. So from maybe 5% mole, you're going to increase it if you keep doing it forever. Maybe like if as time reaches infinity, you're going to achieve around 100%. Okay, but of course we're not going to do this. Probably we're going to do some 5 minutes, 10 minutes, 20 minutes, who knows. And you will expect, of course, to be between this range. Okay, let's continue with the mass balance. We have no outlets. We have only inlet, which is the 20 liters per minute. Production, no, because we have no reactions. Consumption, no, because the same reason. And accumulation, yes, we have accumulation. So our mass balance get into this form, which is kind of nice. And yeah, let's analyze the inlet. Inlet is these 20 liters per minute. And you know we don't like liters, so if we use the density, we're going to have mass per time. And if we have the molecular weight, which is easy to get, we can get mole per time, which is what I want. I want moles because I have everything in moles, and probably they are asking me, let's go here. Yeah, they tell you this little tip, go define NP here as kilomoles. So yeah, let's do the calculations from data book, 3PO4. The density it's something around 1000 1.834 grams per milliliter, and the molecular weight, sorry about that, it's around 98 grams per mole. So let's do it. Let's calculate the input, which will be 20 liters per minute. Actually, let me do it in variables. We will have the density times the volumetric flow, and if we do this will be our mass, and we will need to multiply it by molecular weight to get mass, to get moles. So let's do it. We have our volumetric flow is here, 20 liters per minute. Our density, we just got it from the book. You don't know how to get them, just Google that. And let me change these milliliters to liters, so they can look how these liters and these liters and these milliliters and milliliters are going to cancel, so that's cool. And what else? Yeah, we want to divide, actually we need to divide 98 grams per mole. Sorry about that, this is a division. And we don't want grams or gram mole, we want kilomoles. So 1000 mole, gram mole, it's the same as 1 kilomole. So yeah, let's do this. Look how everything, liters cancel with liters, milliliters with milliliters, grams with grams, gram mole with gram mole. So we are left with only kilomoles per minute, which is what we want. 0.375 will give us the number 20 times this times 1000, actually 1000 and 1000 goes, divided by 98. So we get kilomole per minute. This is our inlet, and we already calculated this. We need to calculate accumulation, which is actually not a calculation, it's a concept, which is the derivative of the moles around time. And when I say moles, because we're doing a mass balance in phosphoric acid, I'm going to choose total moles. So that's cool. We have everything. We substitute this data. Actually, you will get that the moles of P, the derivative of moles of phosphoric acid in time, will yield a constant, which is this here. And look how the units make sense. Up here we have kilomoles of phosphoric acid, down we have minutes, and it's exactly what we have here. So we are in the right path. We have a good analysis in dimensions, so we continue. Now they tell you, let's go up. Okay, at any time. So we want to do this at any time. Yeah. Let's calculate this. We will get the initial condition. They tell you at time 0 you have this small fraction, which is xp will be 5%, which is data. So what you're seeing here, it's a differential equation with the boundary condition. So we could actually solve it. They don't ask us to solve it. They just tell you, please give me this and the boundary condition. We're going to solve it in letter B, which is, let me go up, solve the balance to obtain an expression for NPT. So we need to solve that differential equation. Use the result to derive an expression for XP in time, which is the mole fraction of phosphoric acid in the solution. So let's do it. B is something like, yeah, we have this here before. It's a first order differential equation. It should not be that difficult to solve. I want to change this here, so I got the NP. This is a constant, so I don't need to send it here. I can let it here. And yeah, let's integrate from NP0 to NP final, and the time T0 to final time. Now, this integral will be NP we need to evaluate in NP0 and NP. And yes, 0.375 times T, evaluating T0 and T. So let's evaluate. We get this to the left, and we get this to the right. And yeah, we're done. We just need to use our boundary condition, which we do not have because we need NP0. NP0 will be essentially the amounts of moles of phosphoric acid, which is total moles times the mole fraction of P, which is 150 kilomole of total solution, and they give me this number. This here, guys, it's 7.5 kilomole of P per minute. No, actually, no, it's not. It's just initial moles. Take care, guys. It's only mole. We have no time here. So ignore that. I'm going to take it away. It's only kilomoles per batch. So we have this here. We are going to set this time. We know it's time 0, so we are going to get a nice equation, which is NP minus 7.5 equals, where is it? 0.375 T, because this is 0. And NP equals 0.375 T plus 7.5. Good. We have the equation, but the thing here, guys, it's that we have this here, but they tell you, okay, use this result now, but we want the mole fraction. So essentially, hopefully you know that the mole fraction, it's mole fraction, you know, it's N of any substance divided by the total moles of the mixture. So if we want Y of P, or mole fraction of P, we need the amount of moles of P divided by the total amount of moles. What is that? Well, we need to check we have this, yes, at any moment, which is this here, and the total moles we need to calculate. Total moles at any time will be essentially initial moles, which are water, plus the initial moles of phosphoric acid at the start. So this here we know it's 150, plus the moles at any moment of NP. So yeah, total moles, yes. And since, well, we're going to see later that we're going to cross some numbers, we have this NP, it's phosphoric acid at any moment. Yeah, okay, so let's go to this here. Let's substitute equation number 1. Let's say this is in here. So NP is 0.375 T plus 7.5 divided by NT, which is NT, let's see, equation number 2, which is, let's substitute, it's 150, all these 150, plus this equation here. And just one thing, guys, I might forget, but you need to take out this number because we are counting it as double, so we gotta take it out. This is the initial, actually, yeah, we have, this is a negative, so don't use 150. The best one will be here, you pay, you have this, and yeah, we just gotta do some math. 7.5 plus 0.375T divided by 150 plus 0.375T. So we have this expression here now. So that was letter B. It's actually, this is like B1 and this is B2 because they ask us two things, which is this B1 and B2 I'm telling you. And finally they tell you calculate the time that will take to concentrate to 50%. So let's do letter C. Letter C will be essentially just find the value T, so the XP, or well, actually I use YP. Anyway, we're talking about mole fraction. YP is equivalent to the 50%. So we know YP, then it will be numerically 0.15. We substitute in 3. So 0.15 equals 7.5 plus 7.375t divided by 150 plus 0.375t. And as you can see, this is just an equation. We can look for the time, and we're going to do it. So you just need to change all these to here. 0.15. We multiply 150 plus 0.375t equals 7.5 plus 375t. And yeah, this is, let me check the numbers. This should be 22.5 plus 0.066t equals 7.5 plus this is exactly the same. And I want to check left, I want numbers, and right I want variables. So I get this, which eventually it's going to divide and give you around 47 minutes. So that's the time we're going to take if you want to start your 5% solution. We have phosphoric acid plus water. We're going to add just phosphoric acid. So eventually, as time passes by, you're going to add like 6%, 10%, eventually until you get to 50%. You're going to take 47 minutes. So that's what's the problem. Let's just reanalyze. We had this system. We have phosphoric acid and water at these initial conditions at time 0. We got this amount of kilomoles, and we were adding 20 liters of phosphoric acid per minute. So we do the mass balance and we solve for it. This is the differential equation with the boundary, was letter A. Letter B was to get this equation number 1, amount of phosphoric acid at any time. And because they like to have also the phosphoric acid fraction or mole fraction, they ask you here. So we have these two, equation 1 and 3 are part of B. And finally, letter C, it's just the time that we need to get this value of YP or XP, the amount of mole fraction of phosphoric acid. We just substitute it, do some math, this is just math, and we get these 47 minutes. So that's cool. We have essentially done everything, mass balance, some math, and we are set for this problem. What's up guys, it's me, Chemical Engineering Guy. So if you like the video, why not push the like button? It really helps me to know if you're liking the videos or if I should be changing something or I should be adding something, taking out content, whatever. Also, sharing is caring. So if you got any kind of friends, teachers, colleagues, or whatever kind of person that might be interested in this type of content, why not share it? Sharing helps our community to grow faster in members and in content. If you want to keep track of my activity, videos, uploads, experiments, playlists, whatever content I'm getting on YouTube, be sure to click the subscribe button. Subscribing to the channel is totally free, guys. My dream is to create an online academy of chemical engineering, where everyone can access it in the world. Imagine a place in which the student, the teacher, and the engineer get the best of each other. So thank you guys for the support and the love.